All right, in this video, we're going to start building up our knowledge so that we're going to be able to graph some interesting functions. Our focus will be on polynomials and rational functions for the graphs. Now, if you're doing my lab for your homework, then you're going to notice that you're going to have a lot of options for multiple choice graphs. I warn you that you really need to graph these on paper by hand to make sure you understand what you're doing before you just go and start doing the multiple choice options. If that's open to you, to select the graph, great. It simplifies your work and makes it easier for you to check your work, but always try to do these by hand before you look at the options, because otherwise they start to affect the analysis that you're going to do. So we're talking about graphing, and to start off we need some tests. The first test we're going to talk about is the first derivative test. This is extremely important, but before we can talk about the actual test itself, we have to define what it means for a function to be increasing or decreasing. So definition: a function that is only increasing or only decreasing on an interval is said to be monotonic on that interval. So mono is one, so monotonic means one direction. The function is either going up from left to right or going down from left to right. Always read a graph from left to right. All right, so how are we going to know if the function is increasing or decreasing? That's what this corollary is for. It says, suppose f is continuous. Very important. We're going to be focusing on continuous functions, except for the rational functions, which have vertical asymptotes, but they're continuous everywhere else. And it's differentiable. If you have those conditions, then if the first derivative is positive, your function is increasing wherever your first derivative is positive. If your first derivative is negative, anywhere that's happening, your function is decreasing. All right. To find the intervals where a function is increasing or decreasing, to find where this corollary is occurring, number one, find all the critical points. Remember, we've talked about critical points. We defined it in the previous videos. That's where the first derivative is equal to 0 or is undefined. Okay, now, you know how to do that because we have already done that for the extreme value theorem. But notice in this case, we're not talking about endpoints. There's no endpoints anymore because we're talking about an infinite domain. Number two, put the critical points in numerical order. We did that as well already, but we're going to do it again. Evaluate the derivative in between your critical points. We're going to create what's called a sign chart. In our overall graphing experience, we're going to do two sign charts, the first derivative sign chart and the second derivative sign chart. First derivative sign chart uses your critical points, and you're going to test in between those to see if your function is increasing or decreasing. I'll show you how to do that. Then use corollary 3 to categorize whether the curve is increasing or decreasing between each consecutive pair of critical points. Note, we do not talk about whether a function is increasing or decreasing at a single point. We can use open intervals or closed intervals when discussing where a function is increasing or decreasing unless specified by the problem being solved. So if you were writing your answer on paper, I wouldn't care if you did open parentheses, like open interval, or brackets to tell me where it's increasing or decreasing. My lab is going to specify, I expect, that you're going to answer in a certain way. So if you notice that they're wanting you to answer in a particular way, but they don't actually spell it out and say, use open interval to, or over what open interval is this increasing? Over what closed interval? If they don't specify, you're going to need to learn what they want so that on the test you know. Okay, let's do an example. Find the critical points of this function here. How do we find critical points? Remember? Critical points. Critical points occur when your derivative is 0 or undefined. So how do we find those? Well, first of all, you got to find your derivative. So what is the derivative of this function? So this is just power rule. Hopefully you guys have that down. If not, you need to practice. Ask me for some extra problems if you need it. 3x squared minus 12. That would be your derivative. We want to know where this is 0, so we're going to set it equal to 0, or undefined. Is this polynomial ever undefined? Meaning, if I plug in an x value, will I always get an answer? Yeah, no matter what x you get, you can always square it, you can always multiply by 3 and subtract 12. So this will never be undefined. You don't need to worry about that for polynomials. But you do need to solve for where this is going to be 0. So bring your 12 around. divide by your 3, equals 4. So x equals, all right, how do we get rid of the square? We take the square root. When you take the square root, what do you need to put on? Remember, if the square root's already there, you're good. But if you put a square root, you have to put plus or minus. So plus or minus 2. And there you have it. Those are your critical points. All right, so we found where the derivative is 0. We determined that it's never undefined. Now, we need to identify the open intervals. We're doing open intervals, so that means parentheses. We write our intervals, on which f is increasing and on which f is decreasing. So let's go back up to our steps so I can connect this for you. We've done step 1. Step 2, put the critical points in numerical order. I'm going to put them on a number line. So this is going to be what I call the first derivative sign chart. You should always label your sign charts because you're going to end up with also a second derivative sign chart later on, and you don't want to get confused when you go back and forth reading your sign chart and trying to graph. All right, so our x values are critical points. We have a -2 and a +2. Make sure you put them in order. So -2 and +2. The critical points, I usually put vertical lines at. I'm trying to denote that these are my critical points. I know that my derivative is 0 there. The question is, what's happening in all the other sections? Well, in order for your function to change from increasing to decreasing, it has to cross through a derivative of 0. So if your function is increasing and then it wants to decrease, it has to have a peak. Or if it's decreasing and then it wants to increase, it has to have a valley. Those peaks and valleys are these 2 points here. What I want to know is what is happening to the left. To the left, the function will either be increasing or decreasing for that entire interval of values. It cannot change in that interval. All the points where we change increasing and decreasing are marked as your critical points. So let's pick a number to the left and we're going to test to see what happens to our function. We're also going to pick a value in the middle, so 0, and a value to the right, 3. You can pick any numbers you want as long as they're within those intervals. So I call this testing. When you test, you always plug into the first derivative if you're doing the first derivative sign chart. So plug in, let's see, start with a -3. Our first derivative is right here, so I'm just plugging in -3. So that's 9 times 3 is 27 minus 12. All I care about is the sign. This is positive. So on my sign chart, I'm going to put a big old plus sign here. Here's my plus sign. All right, and we're going to interpret what that means in a minute. Let's just finish testing each point first. All right, f prime, we're going to plug in 0. Remember, you don't plug in -2 and +2 because those are where your derivative equals 0. You plug it in between them. All right, so 3 times 0 squared minus 12. So that zeroes out, and you end up with -12. So negative is all I need. I don't care about the number, just the sign. So in the middle here, we're negative. And the first derivative, if I plug in a +3, let's see, what do we end up with? So that would be 27 minus 12, which is positive. So on the right side here, we get plus. There you go. All right, so we have our sign chart. We've done number 1, found the critical points. Number 2, we put them in order. Number 3, we tested in between the critical points to find what kind of values we get. Number 4, we categorize. So according to the corollary, it says if your derivative, your first derivative is positive, your function will be increasing. From left to right is how you draw it, increasing. So I actually draw it. You can also write increasing, but positive derivative means increasing. Function's going up from left to right. Then you reach a critical point, which means you turn around, or potentially turn around. In this case, you do turn around because the next section is negative. So we have a decreasing function here because the first derivative is negative. And then we have an increasing function because the first derivative is positive. And there you have it. We've categorized every section. So now we can write them down. We are increasing from, let's see, all the way to the left would be -infinity. Always parentheses on the infinities. and it wants open intervals, so we're going to use parentheses everywhere, all the way to -2. The next section is decreasing, so let me write decreasing. Let's see, we're decreasing from -2 to 2. Don't use your test points, use the critical points when you create your intervals. And the last section, we're again increasing, so I put a comma. My lab might want a union, I don't recall, but comma will work for our purposes right now. So let's see, from 2 to infinity, we're increasing. So this would be the intervals and a determination of what is happening, increasing or decreasing. And that answers the question. So that's how you're going to be going about determining which sections of your graph are increasing or decreasing. We're going to keep adding to this information, but this is the introduction to increasing and decreasing. So practice and come watch the next video to learn how to do the first derivative test.